Last year, our group presented work about Internet device graphs, which identify relationships between Internet-connected devices such as smartphones, tablets, and computers. At comScore, a digital analytics company, we use device graphs to report on delivery of advertisements across media. The result is a massive dataset with over 700 million nodes representing cookies or advertising IDs, partitioned into over 100 million cohorts. These cohorts represent digital households and contain identifiers that are frequently observed on the same IP address. In our latest work, we tackle the problem of partitioning these cohorts into fine-grained groupings corresponding to individual devices and users. For example, given that all identifiers in the figure at right share a cohort, we may want to partition the space into the following 3 devices. Our approach to this problem consists of a few steps. Using training data, we build scores for each pair of features. Once we have these scores, we assign an overall score to each pair of identifiers within a cohort. Finally, we run a community detection algorithm on the resulting graph in order to partition each cohort. We use different feature sets for the device and user level groupings. For device level groupings, we rely on the user agent, which is a string included in a client HTTP request. In general, these indicate the type and version of the web browser and operating system. We also build a feature set of screen sizes. For user-level groupings, the feature set is composed of the domains visited and apps used. Using the training data, we compute a score for each pair of features. For example, if in 19 out of 20 occurrences where we see UA1 and UA2 together, the 2 identifiers correspond to the same device, we compute a score of 1 for this pair of features. Likewise, if in 19 out of 20 occurrences where we see these 2 user agents together, they belong to different devices, we compute a score of -1. Note that scores become increasingly positive as we see more evidence for 2 features coming from the same device, and increasingly negative as we see more evidence for them coming from different devices. A score of 0 represents that we have equal evidence in both directions. For each pair of identifiers that share a cohort, we sum the similarity scores for each of their pairs of features. We then interpret these scores as edge weights and perform community detection on the resulting graph to generate a partitioning of the nodes into user or device level groupings.